Have you ever wondered how researchers test different ideas to improve a product, cut costs, or make a service more efficient? It's not just guesswork, it's design of experiments, or DOE. If you've ever wondered what a DOE is and how to make one, stick around because today I'll be giving you the tools you need to get started on your DOE journey. DOE is a structured, data-driven way to test and understand which factors affect outcomes, letting you make smarter, faster decisions. It's about systematically testing to see which variables or factors influence a result. For instance, if you're trying to bake a perfect cookie, DOE lets you test how changes in temperature and baking time affect taste, texture, and appearance. The three concepts I want to talk about today are factors, levels, and the response variables. Factors are the variables you change. In our cookie example, that's the oven temperature and the baking time. Levels are the different sets of each factor, like high and low temperature. And the response variable is the outcome you're measuring, like taste or texture. Another key part of DOE is choosing the right experimental design. There are several approaches, but two common ones are full factorial and fractional factorial. In a full factorial design, you test every possible combination of factors and levels. However, many times we don't have the luxury of excess time or money to do that, so we must be tricky. In a fractional factorial design, you can use a little bit of math to determine the combination that gives us the most information as possible with the limited time and resources we have available. Let's break down the DOE process into 6 simple steps. First, we need to define the problem. Start by asking, what am I trying to achieve? In the cookie example, maybe you want to improve the texture. Second, you need to select the factors and the levels of each factor. Identify the factors you think influence your outcome. Here, that's temperature and time. Then, set the levels for each. Third, design the experiment. Choose the type of experiment based on your goals. Are you testing every possible combo with a full factorial design, or are you narrowing it down with a fractional factorial? This will be mainly driven by the resources you have available. Next, you need to actually run the experiments. Conduct your tests, carefully changing only the factors and levels you planned, and record the response variable. Also, it's important to note that the order you test can be important. Make sure to randomize the testing order to not introduce outside correlations into the data. Fifth is analyzing the results. Review the data to see which factors had the biggest impact on the response variable. This can include analyses like ANOVA, regression, or main effects plots. Lastly, draw your conclusions. Make decisions based on your analysis and adjust your process to the optimal settings. DOE is widely used in manufacturing and product development. For example, in manufacturing, DOE helps improve product quality by identifying the exact conditions that reduce defects. In any industry, DOE saves time and money by optimizing experiments, cutting down on unnecessary testing, and leading to faster improvements. And there you have it. The basics of DOE. DOE gives us a powerful, structured way to test ideas and make data-driven decisions to optimize our products and processes. If you like that content, make sure to hit the like button and subscribe. You can also click that bell icon to be notified of future videos. Now, this was just a basic of DOE, and if you have any questions about how to actually implement any of the processes that I just described, please make sure to leave the comments below, or you can send an email to AskDrAdam@KYZEN.com. Thanks again, and stay clean.